This video was produced by Virginia View, a consortium dedicated to promoting remote sensing outreach, education, and research through funding by the America View Consortium. This video was developed in partnership with the Virginia Geospatial Extension Program and GeoTED UAS. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of America View, the USGS, or other partners. The mention of trade names or commercial products does not constitute their endorsement. Covariance evaluates the correlation of values between the different bands. Low values indicate that values in a pair of bands tend to increase and decrease independently. High values indicate that the values in the two bands tend to increase and decrease together, a high covariance. For effective classification, we prefer to see low covariances, indicating that the training data are providing independent information. In other words, data from training fields are not replicating each other. To evaluate covariance and some other statistics, go to the Analysis tab, Tools, and search for Band Collection Statistics. We'll be using the new clipped images for each of our training samples in this tool. From the drop-down arrow, choose Clip Forest to begin. We'll be running this tool for all 4 images. For output location, leave the default and ensure Compute Covariance and Correlation Matrices is checked. At the bottom, select Run. When it finishes, rerun the tool for each of the training sample clipped composite images. Each time the tool finishes, you'll see a new standalone table at the bottom of the Contents window. To view the results, right-click the first result and select Open. The table opens at the bottom of the map viewer. You can resize it to see it better. This table contains our forest training samples. The data at the top of the table presents statistics for each band's pixel values. We've seen these values before when we viewed the histogram for these data. Next, let's scroll down to the correlation matrix at the bottom. Remember, this analysis is to evaluate the bands and their similarities to each other. So when comparing band 1 to band 1 and band 2 to band 2, the value is 1. They are exactly alike. As values decrease from 1, the bands are more dissimilar. Band 1 is next most closely correlated with band 2. Review the Landsat 8 band sensitivities table at the end of this chapter. The correlation makes some sense since band 1 is used for coastal areas and band 2, blue visible, is used for bathymetric mapping. Both of these bands involve some type of evaluation of water or water-land boundaries. Examine each of the values in the table to understand which bands are more closely correlated with one another. Now let's take a look at the covariance matrix in the middle. Recall that low values indicate that the values in a pair of bands tend to increase and decrease independently. High values indicate that the values in the two bands tend to increase and decrease together, a high covariance. For effective classification, we prefer to see low covariances, indicating that the training data are providing independent information. Now that we've finished evaluating our training samples, and we have eliminated samples, merged samples, and created new samples, we're ready to proceed with classification.